You can't see me. Now you can, because there's a way. Most of the time, issues can be solved by simply seeing the root. But often, the root is hidden beneath the darkness, unable to be spotted by the naked eye. An example of this is when you have your laptop camera broken, and you have to call a technician over to fix it. The only way of fixing it is to open the laptop up, spot a wiring problem, and only then it can be fixed. Well, I wish I could have fixed it myself, since I do study engineering, although not exactly that kind of engineering. My name is Michelle, and I'm a third-year undergraduate student at CUHK. Looking back in time, I really can't believe how quickly time flies. 4 years ago, in 2021, I was still deciding on what I was going to study at university. I had this love-hate relationship with mathematics, but I think I kind of liked it. And then my biology teacher introduced me to DNA, and it completely blew my mind. Because what do you mean that our body has some sort of blueprint? Yet, they're so small, I thought they worked like magic. So, long story short, that's how I decided I was going to study biomedical engineering. And then, 2 years later, I was in the first year of my undergraduate studies, and it was the first time I've ever held a micropipette. A year later, however, in the summer of 2024, I was leading the wet lab part of the CUHK iGEM team. So iGEM stands for International Genetically Engineered Machine, and their competition focuses on using synthetic biology to solve real-world problems. So in a very oversimplified explanation, synthetic biology is similar to electrical engineering, taking wires, connecting them with light bulbs, light switches, batteries, and voila, there you have your electrical circuit. But instead of using electrical parts like that, we use biological parts, such as genes, to create our biological circuit. Instead of lighting up a light bulb, we create a circuit, for example, to change the color of a solution. Now, let's leave the circuit behind for a while, and let's talk about human bodies. Is there anyone in this room who has never been sick before? I'm sure most of us have, right? So imagine this. One day, you get a severe fever, and you go to see the doctor. The doctor then tells you that you have a bacterial infection. So you're given a medicine to take, or specifically, antibiotics. Antibiotics are meant to kill the bacteria residing in your body that cause you to get that fever. But what if, after taking the antibiotics for days, the fever doesn't go away? Except this is not hypothetical. According to Christopher J. L. Murray and his colleagues in an article published in The Lancet, in 2019 alone, 4.95 million deaths were associated with bacterial antimicrobial resistance, and 1.27 million deaths were directly caused by it. And if we take the estimated value from the Our World in Data project, there were 58.4 million deaths in 2019, which means that 1 out of every 12 deaths was associated with bacterial antimicrobial resistance. Now, to explain what is happening to this resistant bacteria, let me introduce you to my friend here, Monia. Well, she's not exactly my friend. As you can tell from her full name, Klebsiella pneumonia. I don't think I really like her. But anyways, Monia lives in a big village called the Blueville. Imagine this as your human body. The majority of the population here is this blue little guys. But there's also another group of beings. They're the source of chaos all over Blueville. If there's any theft in the market or robbery in the bank, this group is definitely the one to blame. The Crimsons, everybody. Luckily, there's also a group of protectors in Blueville called the Guardians. But they're not very competent. They're not specially trained. All they can do is aim and shoot at the right guys. So once their commander tells them to attack, they start shooting the Crimsons at the crime spot, but often shooting off targets. Ouch. Well, the only good thing is it's very effective. The Crimsons are actually killed in the process. Now imagine the Guardians being the antibiotics usually prescribed by your doctors, and in this case, once they finish all their attacks, you recover from your sickness. Ammonia is very smart. So everyone in Blueville must carry a badge that contains every information about you. It also tells whether you are a good guy or you are a Crimson. But Monia developed this magic pill that makes her a non-target by appearing as an innocent villager. Even her badge doesn't really say she's a Crimson anymore. She can steal an apple or two, she can rob the bank, but the Guardians never really target her. Worse, more innocent villagers become the victims of the shooting because of her crime as she swiftly leaves the crime spot unharmed. Knowing that this pill gives her an advantage of not getting killed, she shares it with her fellow Crimsons. Of course, to Monia, sharing is caring. But now, it becomes very difficult for the Guardians and their commander to eradicate crimes in Blueville. They don't know who to target anymore. So they just shoot randomly until they're all exhausted and run out of bullets. A lot of innocent villagers are killed, but the Crimsons are still out there. Antibiotic resistance is similar to this. The antibiotics are unable to kill their intended target as bacteria develop this superpower due to mutation or horizontal gene transfer. But luckily, for every supervillain, there is a superhero, and here comes the Elite team to the rescue. Just as doctors will move on to second-line antibiotics if the first line are found to be ineffective, the commander in Blueville can also call the Elite team. What's special about them is that they have a wider range of attack. So they drop a bomb instead of using bullets. But as you can tell, calling the Elite team at an ideal situation where Monia's magic pill doesn't exist will only result in unnecessarily huge casualties. So we only want to call them when they're really needed, when the pills are everywhere in the village and when almost every Crimsons are disguised. Because we also don't want Monia to observe them for too long and eventually outsmart them with her new tricks. Fortunately, there are a few ways to know whether the Crimsons in Blueville have consumed Monia's magic pill. So the commander has this very expensive security cameras that he places in some parts of the village. But not every part of Blueville has the camera, although it can produce ultra-high definition images that can spot the Crimsons in disguise, but they're expensive. Just as the expensive security cameras test, such as minimum inhibitory concentration, polymerase chain reaction, and gene sequencing, are available to diagnose antimicrobial resistance in bacteria. However, this test requires trained personnel and bulky machines, which isn't feasible in low and middle income countries, although 28% and 21% of the 4.95 million deaths happened in South Asia and Sub-Saharan Africa, respectively, according to Christopher J. Murray and his colleagues in The Lancet. So they definitely need something else to spot this nauticursus. Maybe something faster, cheaper, simpler, and that's exactly what we were trying to do with our iGEM project, ResCSense. Our idea is that instead of relying on expensive security cameras, the commander gives each patrol officer a magic torch. This torch isn't just for lighting up dark alleys. It also has a special ability. Remember the badge that everyone has to carry in Blueville? This magic torch can reveal the hidden truth inside a badge. First, the magic torch scans a badge at a specific section that tells whether you are a good guy or you are a Crimson. Except that the patrol officer can't rate them directly, since they're just too small. How small? Definitely smaller than the size of the bacteria. So to get a clear view of what it is actually written, the magic torch zooms in on the message. Now, this guy is really suspicious. What do you mean, not a crimson? Are we sure you're an innocent villager? After that, the magic torch runs a quick search in its dictionary to check for what the message actually means. And then it expands the message to not a crimson. Or, I lied to you, because an innocent villager's badge wouldn't contain the word crimson at all. Oh my. So to inform the patrol officer what the magic torch just found out, it then shines a blue light, basically telling the patrol officer that the blue in front of him is fake. It's just a crimson with their deceptive magic pill. And with this information, the patrol officer can then alert the commander to send in the elite team to kill these troublemaking crimsons. Remember the circuit that we talked about in the beginning? This is almost like switching on the blue light when we detect something wrong. And with this information, the commander can then send in the elite team only when they're really needed, so that Monia cannot come up with her new tricks to deceive them. In a physical sense, the batch in the story is comparable to genes in bacteria. The added word not A in front of the word crimson symbolizes genetic changes that cause antimicrobial resistance in bacteria. And then using special genetic scissors, the gene can be cut at a precise location, similar to how the magic torch only scans on a specific section. And then using a polymerase, the gene can be amplified, similar to how the magic torch zooms in on the secret message. And after that, we can check the snippet against a rolling circle amplification template that is specifically designed to recognize the antibiotic-resistant gene snippet. If they match, then the RCA process will occur, similar to how the magic torch expands the message after checking for what it means in its dictionary. And after that, this expanded message, or the RCA product, will fold into a structure called the decoderplex DNazyme that causes a color change reaction from colorless to blue. So if the solution doesn't change color, it means that the word not a crimson was not recognized, and it implies that the bacteria does not carry an antibiotic-resistant gene. Well, being an iGEM and telling you the story about Monia have definitely been the highlights of my undergraduate studies. It was intense. I've cried over iGEM with an exam the next day, but I'm deeply grateful. In October 2024, during the iGEM Grand Jamboree at Paris, our project, Resistance, was awarded the gold medal, and we also brought home a nomination in Best Education. This is obviously impossible without the joint efforts from all my teammates and the guidance from all our principal investigators and teaching assistants. Of course, this is just the beginning. There is still much work to be done in the future about our magic torch. Based on estimation, it will be able to provide results within 2 hours without the need of sending your samples to a laboratory. But of course, we do want to shorten the time. No one wants to wait in the security check for a whole 2 hours, right? A thorough expansion of our current proof of concept is also still required to verify the specificity and sensitivity of our kit. We're also aware that sometimes Monia might come up with her new tricks, and her badge will not exactly say not a crimson. It might be not a crimson at all, or I saw him not a crimson, or crimson? Not me. So we're looking forward to further developing our kit, not just to target one resistant gene, but multiple. Our end goal is to make our magic torch multifunctional, just in case some other criminal groups might appear in Bluefield. I don't know, maybe Monia also shares her secret with Stappy, Toko, Nini, Gino, and her other friends. But whatever she's doing, we have to be ready. When bacteria like Monia develop resistance, our first-line treatments become ineffective, making infections harder to treat and more deadly. Without further interventions, including improvement of diagnostics in low and middle-income countries, antimicrobial resistance-related deaths are projected to reach 10 million annually by 2050, according to Jim O'Neill in his written report. Just like how the Magic Torch helped the commander in Bluefield to call the elite team at the right time, our point-of-care testing kit is aimed at making it easier for doctors to make accurate antibiotic prescriptions. Lastly, fighting antibiotic resistance isn't just about better diagnostics. It's about global awareness and action. Just as Monia and her fellow crimsons remain hidden without proper detection, resistant bacteria continue to spread when we fail to recognize the urgency of the problem. That's why we want to encourage everyone to spread awareness, and we will also continue our journey in making diagnostics more accessible. Because in the end, it's your choice. It's our choice. Will you bring Monia into light and expose her little tricks, or will you let her stay hidden for a much longer time until all infections become incurable?